All right. Now, there's, of course, a little bit more that we need to talk about Jupiter and Saturn. And that's the thing that Saturn is most known for. Okay? What is Saturn most known for? You guys should know this one. Yes, the rings. The rings of Saturn. Here's a picture of the rings of Saturn. This is not a very good picture of the rings of Saturn, and that's because this particular picture of the rings of Saturn is taken from Earth, from within our atmosphere. And our atmosphere is essentially the molecules jiggle around so much that it disrupts our images of something this small. But if you take a picture of Saturn from space, it goes from this to this. So this is an actual photograph of Saturn from space. So you can see why we bother putting telescopes on satellites, right? So that said, this particular picture of Saturn was taken from much closer to Saturn. It's not just taken from Earth orbit. Oops, getting a phone call. Let's shut that down. Why do I even have my phone on? Sorry, guys. Let me turn that off. Goodbye, phone. All right. So, let's talk about these rings, okay? Is Saturn the only planet with rings? No. Jupiter also has rings. Actually, all the Jovian planets have rings, but Jupiter has rings. But did you see rings on Jupiter on any of the pictures that I showed you guys? Did you see rings? Here again, here's a picture of Saturn and Jupiter next to each other. See any rings on Jupiter? No. No, we don't. That doesn't mean it doesn't have rings. It just means that the rings on Jupiter must be much harder to see than the rings on Saturn. Okay, so keep that in mind. We'll come back to that in a second. But Jupiter and Saturn both have rings. Jupiter's rings are just much more faint. So, let's look at these rings. Now, let's think about these rings. Are these rings solid, liquid, or gas? Let's figure that out first to see if anybody knows this. Are these rings made of solid, liquid, or gas? Oh, I see people are a lot more afraid to try on this question. That's okay. That's okay. So these rings are solid, okay? They're solid. The rings of all the planets are made of solid, okay? Different planets have different solids, but they're all solid, okay? That said, could you get out and walk around on these rings? Is that like something you could walk on? Probably not. That's correct. I said probably not because it's definitely not. Okay, you definitely can't walk around on them because even though they are solid, don't mistake me, I don't mean that that's one big solid piece, okay? That's not one large, it's not like a frisbee sitting around Saturn here, okay? It is solid, but instead of being just one big piece, it's actually made of several pieces. So if you zoomed in on those rings, you'd see it's not just one ring, it's actually lots of rings. And if you were able to zoom in enough, you'd probably see something that starts to look like this, okay? This is not a photograph. Everything else I've showed you were photographs, but this is not a photograph. We haven't gotten a camera close enough to get this close of a picture here. So basically, these rings are very, very similar to an asteroid belt, okay? They're very similar to an asteroid belt like the sun has, but they're just around these planets instead. That said, what are they made out of? If you look right here, they're coloring these in this artist's rendition here. They're coloring these a sort of shiny white color, and this is supposed to represent the rings of Saturn. Can you figure out what they're trying to say these rings are made out of on Saturn? Does anybody know what the rings of Saturn are made out of? Ice. Ice. Now, there is rocky material in there, but there is a lot of ice mixed into the rings of Jupiter. And that's mostly water ice and dry ice, the same kind of ices that we've been talking about. And that is why the rings of Saturn are so easy to see. Why is the rings being made of ice important? Why does being made of ice make the rings of Saturn easy to see? What is it about ice? Yes, ice is highly reflective. You guys are figuring it out. Essentially, because ice is so shiny and reflective, you can see the sunlight bouncing off of it a lot better. Okay? All right. So what does that imply about the rings of Jupiter? If being made out of ice makes the rings of Saturn easy to see, what could we probably guess about the rings of Jupiter? Not ice. That is correct. The rings of Jupiter do not have very much ice in them. They're mainly made out of rock, okay? And rock is not as reflective, so it's much harder to catch the sunlight bouncing off of the rings of Jupiter. So if Jupiter's rings were made out of ice, they would be a lot easier to see, like Saturn's, okay? Now, here's the follow-up question. Why are Jupiter's rings not made out of ice? What makes it hard to have ice? And here's a hint. It's something to do with where Jupiter is. The heat of the sun melts ice. And as some of you are saying, Jupiter is closer to the sun. And so essentially Jupiter is just close enough to the sun that sunlight tends to melt ice in space at that distance. So if Jupiter had formed a little further out, it could have had rings just like Saturn. But because Jupiter formed too close to the sun, the heat of the sun melts ice at that distance, and you're left with just rock in the rings of Jupiter. Okay? All right. Now, we're almost done talking about these rings. There's the last thing I want to talk about is how come these planets get to have rings and Earth doesn't get to have rings? How come the terrestrial planets don't get to have rings? Don't answer that question yet. I know some of you might be able to guess it. But in order to answer that question, let's talk real quick about how the rings form. And again, my document cam, I was going to draw a couple of pictures here, but the document cam that I got from the school isn't working for me right now. So we're going to have to use our imagination here. And I'll sort of use this picture of Saturn to help us out, okay? So imagine that this is Saturn right here. And imagine that my fist is a moon, okay? Does every part of does every part of this moon feel the same amount of gravity from that planet? The answer is no. I'll go ahead and say that one just to roll this along. Which part of this moon feels the most gravity from the planet? Which part of this moon feels the most gravity from that planet it's orbiting? We've talked about this in a few videos. Yes, the part that is closer to the planet. So if the moon was right here, let me move this up a little bit. If the moon was right here and the planet is over there, that means that because this side of the moon is closer to the planet than this side of the moon, this side of the moon would feel more gravity than this side of the moon, okay? And if I took that moon and moved it closer to the planet, the difference between one side and the other will increase. And if this part of the moon is pulled stronger than this side of the moon, it's going to do something to the shape of this moon. As this moon gets closer to the planet, what's going to happen to the shape of this moon? Yeah, it's going to stretch out. So the closer the moon gets to the planet, the less perfectly round it will be, and the more oval or egg-shaped it will be. So if it's way out here, it'll be more perfectly round. If it's here, it'll be stretched out a little bit. So out here, round, here a little more egg-shaped, here even more egg-shaped. But are moons made of very stretchy material? Are moons very stretchy? No. No, they're not. They're made out of mostly rock, and at this distance you start getting a lot of ice mixed in too. So rock and ice, which are both not very stretchy. You can stretch them a little bit, but if you stretch them too much, if you stretched a moon too much, what would happen to it? You guys can figure this out. If it doesn't stretch, it would break. So if you got a moon too close to a planet like Jupiter or Saturn, it would break into bits. But as long as that material was already orbiting the planet, then the bits, the broken bits, would continue to orbit the planet. But those broken bits don't all have to orbit at the same speed, so they can spread out. So what could all of those broken bits form if you've got these broken bits orbiting close to the planet? Yeah, that's your rings, okay? So essentially, there is a danger zone around every planet, okay? There's a danger zone around every planet where outside of the danger zone, the gravity of that planet is not pulling on that moon enough, or on that material enough to keep it from forming a moon. Whereas inside the danger zone, the differences in gravity from one side to the other would tend to break those bits apart and not allow moons to form and make rings instead. Okay? So, I'm not necessarily saying that the rings are entirely made out of broken moons. Some of the material of the rings could have just been too close to the planet to ever form a moon, but at least some of this material has probably been formed by moons that have gotten too close and have been ripped apart. Okay? So there's a danger zone around every planet. And there actually is a technical term for the edge of that danger zone. It's called the Roche limit. And that's a little bit of a weird word. It's spelled R-O-C-H-E. The Roche limit is the edge of the danger zone. So that inside the Roche limit, so over here, inside the Roche limit, you're going to form rings because of the gravity of the planet. And outside the Roche limit, you would tend to form moons because the gravity is not strong enough to rip the material apart. Okay? So here is the next question. Here we go. Does every planet have the same size Roche limit? No. My question for you is, what about a planet determines how big the Roche limit is? What about a planet determines how big its danger zone is? You guys are basically getting it. It's the mass of the planet, which means it's the gravity, right? So the gravity of the planet, the higher the gravity, the bigger the danger zone. And the bigger the mass of the planet, the bigger the gravity. So which planet probably has the biggest danger zone out of any of these planets? Which planet has the biggest Roche limit? Jupiter. So yes, if Jupiter had formed at the same distance as Saturn, it would probably have rings that are even cooler than Saturn's. But it's just in the wrong place to do it because it doesn't have that reflective ice. That said, let's put this all together. Can you figure out why Earth and the terrestrial planets don't have rings? Why does Earth and the other terrestrial planets not have rings? Yeah, you guys are putting together all the parts. Because Earth and the terrestrial planets have a much lower amount of mass than the Jovian planets, that means that they have a much lower pull of gravity. And that means that their Roche limits are very, very small. I believe that the Roche limit of the Earth, it's been a while since I've done this calculation, so I might be a little off, but I believe the Roche limit of the Earth is inside of our atmosphere. So if you tried to form a ring inside of our atmosphere, what would the atmosphere do to all of the bits that you were trying to make a ring with? Think you guys are going to get it. Yeah, essentially the air resistance would cause them to fall. Essentially, they would probably break up in the atmosphere and fall. So essentially, the Roche limits on the terrestrial planets are just too small to have rings. Okay, one last picture I wanted to show you guys. You probably have seen pictures of Saturn that look kind of like this, but I did want to show you this picture of Saturn. Because it turns out these are the rings right here that you know about. The rings of Saturn actually go out all the way to here. So the rings of Saturn are much bigger than people actually know. So the Roche limit on Saturn is actually even bigger than it actually looks, that you would guess. Okay? So, yeah.